Video solution to a 3-mark question from the chapter Real Numbers. This question has got two alternatives, 1 and 2. Question number 31 of the sample paper. First one is a very straightforward textbook one. We'll go through the textbook proof and finish that. The second one actually is a question from the NCERT exercise 1.1, question number 3. We'll be having solutions to both these questions in this video, and we'll follow it up with two bonus questions. I'm going to leave you with number changed, scenario changed versions for both the alternatives, 1 and 2. Try both those questions and post your answers to the forums and the comment section. Right? Let's get started with the first one. Prove that 5 minus root 3 is irrational, given that root 3 is rational. Textbook approach is as follows. We're going to assume to the contrary. We're going to assume the opposite. We'll have to prove that 5 minus root 3 is irrational, but we're going to assume that 5 minus root 3 is rational. What's the definition of a rational number? A rational number can be expressed in the form a by b, where a and b are co-prime integers and b is not equal to 0. So what is the objective? How are we going to go about it? We're making this assumption and we'll end up with this scenario to check out whether you're getting root 3 is rational or irrational. If we get to the contrary of what root 3 is, then we know that our assumption is incorrect, and therefore we can say the correct answer is 5 minus root 3 is irrational. Let's set about doing that. We said that if 5 minus root 3 is rational, it can be expressed in the form a by b. I'm going to take the a by b to the left hand side and root 3 to the right hand side. So what we'll end up getting is 5 minus a upon b. This is equal to root 3. Let's take b as a common denominator for the left hand side. So what we'll get is b 5b minus a. This is equal to root 3. Because b and a are integers. 5b minus a is an integer. Upon b is an integer. Integer upon integer is a rational number. So 5b minus a upon b. This is rational. That's evident. There is no doubt at all. But we know this is equal to root 3, which means root 3 should also be a rational number. But what does the question mention? Question mentions root 3 is irrational. We also know that root 3 is irrational. If what have we got by making this assumption? We have got root 3 to be a rational number, which means our assumption is incorrect. The assumption that we made that 5 minus root 3 is rational is incorrect. So we proved that 5 minus root 3 is irrational. I'll quickly run you through the steps that you need to be writing in the examination to get 3 marks for it. Right? Let's get started with that in the next slide. Right? We said that this is the second step. You'll say we are assuming to the contrary, which means that 5 minus root 3 is equal to a by b. You'll solve it to bring it to this step as we got 5b minus a upon b is equal to root 3. And we'll say that 5b minus a upon b is rational because a and b are integers. Therefore, root 3 is also rational. Whatever I spoke there, I've written it here. But we know that root 3 is irrational, which is contradicting what we have got here. And that's because of our incorrect assumption that 5 minus root 3 is rational. If our assumption that 5 minus root 3 is rational is incorrect, then what is the correct one? The correct one is that 5 minus root 3 is irrational. Write these steps, you'll end up getting 3 marks. Let's move on to the second alternative. This one is exercise 1.1 question 3. We'll quickly run through this and we'll also go to the 2 bonus questions that we'll have to solve. An army contingent of 616 members is to march behind an army band of 32 members. 2 groups of people. One group has got 616 people. The second group has got 32 people. The 2 groups are to march in the same number of columns. For example, let's say they are going in so many rows. Each column will be having, let's say, so many people. The first group will also march in n number of people in a column. The second group will also march such that there are n columns in each row. That's what they're saying. Both these groups are going to be marching with the same number of columns. What is the maximum number of columns in which they can march? That's what we have been asked to find out. Right? Let's say the number of people in each row or the number of columns in which they are marching is equal to n. Therefore, we can say 616 people will be marching as n columns and x rows. And 32 people will be marching as n columns and y rows. The number of rows obviously will be different because you have 2 different number of people. So it's quite evident that 616 is divisible by n. And 32 is also divisible by n. Which means, what do we know? We know that n is a factor of 616. We also know that n is a factor of 32. Which implies that n is a common factor. It's a factor of, which means it's a common factor of both these numbers 616 and 32. What do we have to find out? We have to find out the maximum value that n can take. N is the common factor of 616 and 32. We'll have to find out the maximum value that n can take, which means that what we're actually finding out is the highest common factor. Highest common factor of 616 and 32. HCF, let's find out using the prime factorization method. Step 1 of the prime factorization method, we're going to be prime factorizing both 616 and 32. 616 will prime factorize as 8 times 77. 8 is not a prime number. We can write it as 2 cube. 77 can be written as 7 times 11. So prime factorize 616. 32 is very easy to prime factorize. That's equal to 2 power 5. Step 2 is actually computing the HCF. HCF is nothing but the product of the common primes in their lowest power. What are the common primes? The only common prime to these two numbers is a 2. The power of 2 here is 3. The power of 2 in the second number is 5. So the lowest power is equal to 3. So HCF is equal to 2 cube, which is equal to 8. What is the HCF? HCF is the maximum number of columns in which they can march. So both these groups, the army and the band, will have to march in columns of 8. Quickly summarize it in a printed form. They'll be marching in columns of n people. 616 is divisible by n. And 32 is also divisible by n because 616 can be written as n times x and 32 can be written as n times y. When x and y are the number of rows, don't bother about x and y. They're of no consequence to this question. Our objective is to find out the highest value of n. It's quite evident that n divides 616, n divides 32. n is a common factor of 616 and 32. The maximum value that n can take is the HCF of these two numbers. Prime factorize both these numbers. 616 is a 2 cube times 7 times 11. 32 is a 2 power 5. HCF is nothing but the product of the common primes in their lowest power. The only common prime is 2. In its lowest power is 2 cube, which is equal to 8. So both the army and the band will have to march in columns of 8. The two bonus questions that I mentioned are here. This is for the first alternative. This is for the second one. Read the second one carefully. Check out what you have to find out the LCM or the HCF. Compute the answer and post it in the comment section and the forum to check out whether your answers are right. Best wishes. Before you leave, do two things. Sign up at online.maxtute.com for CBSE online coaching for class 10 maths. It takes less than 5 minutes in all of 3 steps to get started. And do one more thing. Subscribe to this channel, youtube.com/maxtute, and spread the word about this channel to your friends and classmates.